Hello, this is Matt Asher with statisticsblog.com. I'm going to be reviewing Mathematica 9 from Wolfram Research. In particular, I'll be focusing on using it with R and to do Monte Carlo simulations and other statistical work. You can find a full transcript of this video at my blog, including the source code and links to all of the web pages I mention. Before I begin, I'd like to thank Jeff Hara and Andy Ross from Wolfram for their time. Also, thanks to the folks at the Mathematica Stack Exchange who helped with a couple of my questions. I'm going to get started here with a blank notebook. And I'm going to begin by clearing out all of the variables that exist there. I find sometimes that if they're existing variables, it causes a problem. And after each line I'm hitting Shift Enter, and that runs the command as opposed to just showing it. So I've cleared my variables, and then I'm going to run needs Rlink, which will bring in the link between Mathematica and R. I'm going to make sure it's installed. And then I'm going to run a test command here to make sure that everything is up and running okay. And as you can see, this is the version of R that I'm running, and the connection succeeded. So note that the free version of Mathematica, the evaluation version of Mathematica, doesn't come with support for R. So if you want to test out Mathematica and its interactions with R, you either have to buy the full version, or maybe if you call up or contact Wolfram, they'd be willing to let you have a free evaluation version that is full and allows you to test out the R. So how does the interface between R and Mathematica work? Basically, you can run operations in R, then store the result to variables in R. You can also pass data types back and forth between R and Mathematica. Here I'm setting a variable, and this variable is set in R, not in Mathematica. So if I were to type just Hal, there is no response back. This is Mathematica's way of saying that the variable here is undefined, or that it doesn't know what to do with your input. So to get back information from R, we have to use the R evaluate, and then we're putting HAL in quotes here so that we are parsing this in R and not in Mathematica. For example, we can do things like grab a data set from R. I'm grabbing the famous iris data set in R, and I am pulling it into Mathematica. Or I could do things like evaluate a command in R and bring back the results. This grabs the determinant of a random matrix here, and I can even do things like create our own functions, create a function in R, and this gets put into a variable in Mathematica. This function creates a perfect sample of the length that you specify of a particular distribution, and then we can call that function directly in Mathematica, like so, and the results are returned. And of course, if we just wanted to do things in R, then we would be continuing to just use R instead of having to learn this new interface between R and Mathematica. So then what can we do in Mathematica that goes beyond what we could do easily in R? One of the biggest advantages to using Mathematica is that you get access to tools for creating interactive plots and simulations that can be changed on the fly. I'm going to do an example using the Benini distribution, which according to Wolfram's web page can be used to model the weight of cats. So to do that, what I'm going to do here is use the Mathematica command manipulate, and here's the code for that. And then I get back the results, and what I've got here is a live simulation, a live Monte Carlo simulation, where I am specifying the different parameters of the distribution, and I'm also specifying how many variates that I'm creating, and this is the smoothing the kernel width here that I am adjusting. And I can adjust the size of this here perhaps. Make it bigger, and do all of these adjustments on the fly. As you can see, you've got some good power here for generating interactive plots and simulations, and you can do these natively right in Mathematica, or you can do live manipulation of results coming from R. This example here comes from the Mathematica guys, and I'm going to run it. And what's going to happen here is I am calling an R function, doing all of my calculations, and then bringing them back into Mathematica. I forgot the manipulate part, so here we go. And what's happening, as I say, is everything is being sent to R for processing and then coming all the way back to Mathematica. And as you can see, even though we're making that round trip, the results are still coming back at a good pace. It's almost instantaneous for this particular example. What about though speed more generally? I tried creating some random variates like I did in my examination of JavaScript versus R. You can find that on my webpage as well. So I'm going to do here 10 million random variates from a normal distribution, and that takes about a quarter of a second, a little bit more, which is about twice as fast as R for generating those. But then let's look at a more of a worst case scenario. Here's a bunch of nested loops. 3 of them, a total of 1 million loops that it's going through, and this takes about 1.2 seconds, and it will increase by an order of magnitude if I add an order of magnitude in here. That is slow. In fact, it's about twice as slow as the same code would take to run in R, and R is not a language that's known for the speed of its loops. Of course, this is generally speaking not what you want to do if you want to run fast code. Mathematica itself on their website advises against using these kinds of procedural codes. But at the same time, I've found that there are times when there really is no other way to do things, especially if you're doing simulations with a bunch of objects that take place over time that are iterative, in which case you do need a structure, a programming structure that's like this, so you'll have to keep that in mind in terms of the speed. Besides the live graphical manipulation of results, another key benefit to using Mathematica is that you can do direct probability calculations, and sometimes you'll even find closed form solutions for combining random variables. I've got some code here that determines the probability that one standard normal variable will be greater than another standard normal variable, and it is of course a half, so it's a simple example. We can definitely do things that are more complicated. I'm going to look here now for a more general solution when you have 2 normal variables with mean mu1 and mu2, and we're going to try to find the probability that one of them is greater than the other. As you can see, it's taking more time to run this calculation, and eventually we get back the response, and we do have a closed form solution. In ERFC stands for the complementary error function. You can check that out on the Mathematica web page. Unfortunately, not all of the problems that I tried to do work, and sometimes they just freeze up completely. So here I'm running a query to Mathematica to try to find the probability that a Poisson 5 will be greater than a Poisson 10 random variable, and I found that this just freezes up and will not return a response, though I only waited a certain number of minutes. Actually, one time I ran it, it locked my computer up entirely. The other time I gave up after a few minutes. I'm going to hit Alt, comma, I believe here, to abort the command and back out of that, and make sure that we're back here. By comparison to R, you can do the same calculation here as comparing 2 of the Poissons. Oops, I need to make sure that that is run in R. So I'm going to run that here in R. I've ran it a couple times already, and it takes about 0.9 seconds to run this. Of course, this is not trying to find a closed form solution, but for me anyway, most of the time these are perfectly good solutions, numerical solutions to the problem. So going back into Mathematica, besides getting closed form solutions for probabilities, you can also combine distributions. You can do convolutions and see what kind of formula you get back out. I found this worked fairly well for simple, well-known distributions. I do it here for the normal. I'm adding two normally distributed variables together, and we get back out very quickly the formula for that. But what happens if we try to work with a less well-known distribution? In fact, let's go ahead and see what happens if we want to add together cats and find out the final weight here. And apparently cats don't add so well. I tried this one as well a couple times and wasn't able to get results returned from Mathematica, unfortunately. So besides these, I'm going to abort that, besides these bugs and issues, there's a couple other significant downsides to using Mathematica. Sharing results over the internet can be done. You can export your notebooks to HTML, but people, if they want to use the interactive graphs, they'll need to have a special plugin. I asked the guys from Wolfram if they knew what % of web users already have this installed. They didn't know. I suspect the number is very low, much lower than, say, the number of people who have Flash installed. Of course, R by itself doesn't provide much support by way of sharing things over the web, though R Studio makes something called Shiny here that can do some export over the web. I haven't checked that out yet very much. I plan to do that soon. So beyond sharing, the biggest impediment to using Mathematica on a daily basis, I think, is the interface, the GUI. I'll bring in some of the buttons here, the palettes of buttons. Overall, the look is extremely crude. Things are disordered. The floating palettes have buttons of different sizes, various places. And it looks essentially like something that you might have hacked together in Visual Basic 15 years ago and then hadn't been touched since. Clearly the era of modern interface design is past Mathematica by, at this point, even open source programs that began with horrific interfaces like the GIMP have now begun to focus on making their interfaces look good. And looks may seem superficial, but if you are going to be working with an interface like this, if you are going to be paying $1,000 for a license of Mathematica, I don't think it's too much to expect that the design be easy to use, that it be easy to find things, and that there be cues as to where different things go. Color certainly would go a long way to help with that, as would other cues to help out. So I'm going to bring back in Mathematica here. Based on the GUI, I wonder one more thing about the GUI. If you're moving the palettes along, it doesn't do ghosting, so it's, oh, pop, there it pops back in. But despite these issues, I can see using Mathematica as an occasional tool to find exact results for probabilities and distributions, or quickly testing out how changing parameters affects a distribution's shape. For now, though, I'm going to continue experimenting with JavaScript, and again, you can read about my experiments with that on my webpage as an alternative to R that runs code quickly, and also I'll be looking some more into Shiny. Make sure to check out the links related to this video at statisticsblog.com, and if you like these videos, click on the subscribe button.